which is a little dirty, it'll create a little bit of a, this will go almost, you can see there's a little dirt on the tip where I cleaned it, but it'll burn that off and then it'll go real clean.
Yeah.
There it goes, it's going cleaner now. But now this is not super hot. Now I'll show you. This is steel, right?
Mm-hmm.
Steel conducts heat.
Pretty quick.
Yeah, you wouldn't be able to hold that
Really?
if you heated it
There
up.
we go.
You're cutting through it? Oh,
If
you're
I
just
get next to it, yeah. Grab the bottom.
What? Is it warm?
Until you get way up there.
It's a chemical reaction.
Yeah.
It's not
Thermal heat.
It's not the heat that you're used to playing with. That's why we can weld dissimilar metals. Is what's happening is, okay, here I'm running my hand. Now this, in theory, should be burning at 6,300 degrees Fahrenheit. Hydrogen and oxygen. It's one of the hottest fuels out there.
Right. Huh.
Didn't burn me.
What temperature? What temperature is it burning at?
It's only burning a little, right at about 200.
Really? So
Now,
the temperature that
here's
most water boils at.
Here you go. Come on over here. This is water.
Right.
You can feel the temperature. That's regular water. Okay.
Yeah.
That's room temperature.
Yeah.
Okay. Now, if this was burning at 6,000 degrees, this would heat up pretty fast, right? You know, changed a couple degrees. That's about it.
Yeah. Maybe lukewarm.
Right.
Maybe a little.
Now, watch what happens when I touch the side of this.
The metal. Right.
You can see the steam already coming off.
Right.
Now you're actually seeing the shock wave of the electrons traveling through the side.
Is that what I'm seeing?
Look right in there.
Through the
See,
surface.
See? But now look at the water forming down here. This is going back to water. From the
On the
torch.
outside.
Yeah. That's what the water is down here. Look at it. How's it going? See, that's the water.
So it's like a glass condensing with ice water in it
Yeah.
on the outside.
Now, you can see it's starting to go into a microwave boil. If we get under it, it'll go into what we call a microwave boil.
Oh yeah. That's a rolling boil.
Interesting. Now,
It's fantastic.
here's a piece of aluminum. Watch this. You see the water build up. Watch this.
Yeah.
Sure enough. Okay. Now here's a piece of aluminum.
Still wet.
Yeah. It's wet. Water. Okay. Here's this piece of aluminum, right? Now, when you get next to it, you'll see it initially create the water until it gets a little warm.
Yeah.
Now, right there, it's molten. Look at this.
That's molten.
But it's not turning black.
With no shielding.
No shielding glass. Okay.
That is the coolest
Now
thing
here's a piece of copper. Now copper is cool. That's why this water's getting hot. The copper's trying to react with the gas and go to several thousand degrees. That's why I'm able to get it to boil. It's not the heat of the
ever.
flame.
It's not thermal
No, I
transfer
run my
of
hand.
heat.
Run your hand through it. Just run
Alright.
your hand through it.
Oh yeah, it feels.
It's wet. It's a clammy. Now here, watch this. When you touch this, in a second, this will kick. Right there, it just kicked. Now just the presence of the gas, the whole piece will just sit there and glow. If I get next to it, it gets brighter and brighter until I finally actually just make it come apart. But look at this. The whole piece is
Wow.
reacting with the gas.
I've never seen that shade of orange.
Yeah. Now here's, ceramic is its favorite. Now watch this. This is cool. Ceramic is really cool. Now this, if I get on it, it'll blind you. But I can stay back a little, temper it a little. Now we're taking a gas that's burning at about 200 degrees and going up to thousands of degrees. So now I can get this thing, if I get next to it, it'll blind you. I mean, it'll light up the whole room.
What is it about the properties of ceramic that...
They're inorganics which really like to react with the flame. That's why we can burn coal clean. I actually get more heat out of the inorganics in the coal than I do out of the coal.
Wow.
I don't need to clean the coal. I like it dirtier than dirty. I get way more heat, and it burns clean.
It's like coal is like almost like a byproduct. Like you just want the dirty, not even the coal.
So this is just some of the stuff that you can do, but you see when you're working on it, you get the water, and like when we heat, water will actually drip off. Now that particular water that drips off there, that's a whole different structure of water.
Is that water water?
No, it's way different. But that's something we'll go into later.
Okay.
That's a whole different animal. We've done some testing with that. It's a high surface tension water. You can put it on the table and chase it around with a magnet, or you can take your fingernail and roll around like a BB.
Wow.
You can play with it. Yeah, that's a whole other water that developed. But
Does it have like different thermal conductivity?
well, this does. This water does.
Okay.
On top. We actually use that. I'll tell you about that in a minute.
Okay.